Hi students, how are you? In last class we discussed about chemical equations, how to balance the chemical equations. Then combination reactions we discussed. So today's class we will discuss about decomposition reactions and displacement reactions. So let's start our class. The first reaction is decomposition reaction. What is the first reaction? Decomposition reaction. Decomposition reaction. So in this decomposition reaction, see first what is the definition of decomposition reaction? So in this decomposition reaction means a single reactant breaks down to give simpler products. This reaction is a decomposition reaction. So generally we can say A gives rise to B plus C plus plus D, anything. So one reactant is splitting into the two or more products. That reaction is called as a decomposition reaction. So decomposition reactions does not take place simply. So it requires some amount of energy. Without energy, the decomposition reactions does not start. So we have to provide the energy, then decomposition reaction will take place. Otherwise, not possible. So we can give the energy in the form of heat, the form of electricity, in the form of light. In three cases, the decomposition reactions takes place. So we will discuss each different examples to understanding the decomposition reaction. So okay, the very first one, thermal decomposition reaction. So thermal decomposition reaction means the decomposition reaction takes place in the presence of heat. That reaction is called as a thermal decomposition reaction. In the textbook, they given one activity 1.5. Here, we have to take one test tube. In that, 2 grams of ferrous sulfate. 2 grams of ferrous sulfate crystals we have to take. So ferrous sulfate means what is the formula? FeSO4. It is a hydrated salt, that's why 7H2O. So okay, 7H2O. So what is the color of the ferrous sulfate? So color of ferrous sulfate is a green color. Ferrous sulfate formula FeSO4 7H2O, which color is green color. So next we have to boil the test tube over the flame of burner or a spirit lamp. So let you see what happens. What reactions takes place. So this ferrous sulfate is converting to brown color. See, so we have to do the activity. So whatever we seeing in the picture. See, so ferrous sulfate on heat. The presence of heat, it is converting to. So what is the name of Fe2O3? Fe2O3 means here -2, here +3. So this iron can exhibit a variable oxidation state, showing a variable oxidation state. So in the case of +2 means iron having +2 oxidation state means we can call as a ferrous sulfate, or otherwise +3 means we can call as ferric. So here what will form? Ferric oxide. So this ferric oxide color is a brown color. So this ferric color, what is the color of ferric oxide? Brown color. So then two gases will rise. How we can find out that these two gases means when these two gases means Which smell we can observe? So burning sulfur smell we can observe. What we can observe? Burning sulfur smell. Burning sulfur. Here two gases. One is sulfur dioxide. Another one is sulfur trioxide. Sulfur trioxide. So here one thing you remember. So first we have to observe inner walls of the test tube. Water droplets. Why, sir? Why are observing this water droplets means this ferrous sulfate is a hydrated salt. So what is the meaning of hydrated salt? So the formula of salt contains water molecules, fixed number of water molecules. That is called as a hydrated salt. So here ferrous sulfate have first this ferrous sulfate FeSO4 dot 7H2O. So this is a hydrated ferrous sulfate. What we call this is hydrated ferrous sulfate. Ferrous sulfate. So this hydrated ferrous sulfate color is green color. Hydrated ferrous sulfate color is green color. When we are starting, we have heating means we can get FeSO4 plus 7H2O. These water molecules are observed on the inner walls of the test tube. Where we can observe this? Inner walls of test tube. Inner walls of test tube. So then what is the color means here? Pale green color we can observe. Pale green color. Like white. Pale green color we can observe here. So then this reaction will take place. This reaction will take place. So everyone should keep in our mind. So in the presence of heat, ferrous sulfate is decomposed to form ferric oxide, sulfur dioxide, sulfur trioxide. So here ferrous sulfate color is green color. Then it will be converted to ferric oxide brown color and remaining a sulfur dioxide and sulfur trioxide, getting which smell? Burning sulfur smell. So okay, so which type of reaction this one? Decomposition reaction. Why? Because one reactant is splitting into the two or more products. So next you can see you can observe the another example. This is calcium carbonate. Calcium carbonate means so where this calcium carbonate is present? First question. Generally we have to observe limestone, marble, chalk. These three contains calcium carbonate. So okay, and egg shell also. In egg shell which is present, which compound is present means we can say this calcium carbonate which does not dissolve in water. Keep in your mind, calcium carbonate not dissolved in water, not dissolved in H2O, not dissolved in H2O. This point everyone should keep in our mind. So calcium carbonate on heating we can get the calcium oxide and carbon dioxide. This is calcium oxide. Calcium oxide is another name is quick lime. So here a limestone heating, a quick lime we can get. Quick lime and liberation of carbon dioxide gas. So this reaction takes place in the presence of heat. Sometimes you can put the delta symbol also. So that's why this is a example of thermal decomposition reaction. So this one more thing, calcium carbonate does not dissolve in the where it cannot dissolve in water. It does not dissolve. Okay, but calcium oxide is dissolved. But calcium carbonate does not dissolve. So it is what reaction this is? Thermal decomposition reaction. Thermal decomposition reaction. What are the sources of calcium carbonate? Where calcium carbonate is present? Limestone, marble, chalk, etc. Okay. So this is about thermal decomposition reaction. Next, we have to observe the one more example for this thermal decomposition reaction. See, they given 2 grams of lead nitrate powder. So what is the lead nitrate formula? PbNO3 taken twice. Lead nitrate. So what they taken in the test tube? Lead nitrate taken. How many grams? 2 grams. So just boil the test tube. Whatever we are showing in the picture, like that we can boil the test tube. So, okay. So in this case, what you have to observe means the lead nitrate is a single. This side you can see only single reactant is there. So what is that? Lead nitrate. Lead nitrate is decomposed, break down into 3 substances. 3 substances. One is lead oxide. What is that one? Lead oxide. So lead oxide will form. So and this NO2 gas also releases. How we can find out this NO2 gas? Nitrogen dioxide gas. Brown color vapors. Which brown color? Reddish brown color vapors we can observe on heat. Reddish brown color vapors we can observe in this activity. And oxygen gas. So lead oxide will form. So where lead oxide is present? In the test tube only. In the test tube only it is present, but remaining we can observe the reddish brown color vapors. The test tube. They are coming out. The reddish brown color vapors coming out from the test tube. So, okay. So this is about these 3 reactions are examples for decomposition reactions. The 3 examples were given for thermal decomposition reaction. So what is thermal decomposition reaction? The decomposition reaction takes place in presence of heat. That reaction is called as a thermal decomposition reaction. So, okay. I hope you understood. Next, electrolytic decomposition reaction. Electrolytic decomposition means the decomposition reaction will take place in the presence of electricity. The presence of electricity, those reactions are called as electrolytic decomposition reactions. So these electrolytic decomposition reactions are also called as electrolysis process. What we called electrolysis. Electrolysis also we can call. So in this activity, we have to take one mug, plastic mug we have to take in, and 2 test tubes or 2 electrodes, graphite rods. 2 graphite rods are taken. They are connected with rubber cock. So they are coming out outside. So one graphite rod is act as a anode. Another one is act as a cathode. So these anode and cathode are connected with 6-volt battery. So here switch also arranged. So on the 2 electrodes, we have to put 2 test tubes. And we have in this we can add few drops of sulfuric acid. So why? Because sulfuric acid, so actually we are taking mineral water or distilled water. In that we can add sulfuric acid. Why? Because it can produce ions. That's why we should add this sulfuric acid, pure drops of sulfuric acid. So when you are switching, we can provide the electricity, so we can observe in the test tubes some bubbles are coming out. So in these bubbles, 2 test tubes, we can find out the 2 bubbles. So in which in where oxygen gas is liberated, in where hydrogen gas is liberated. So the hydrogen gas is liberated to cathode. Hydrogen gas is liberated at cathode and oxygen gas liberated at anode. So just you observe this cathode and anode. So which having more space, can occupy more space. So this is oxygen, sorry, the oxygen, hydrogen. So okay, at cathode oxygen, at anode oxygen and cathode hydrogen. Where more space is present, oxygen is more than oxygen, hydrogen is more than oxygen. Hydrogen is more than oxygen. So why oxygen, hydrogen gas is formed more than doubled than oxygen gas? Means once you observe the reaction, if you observe the reaction, hydrogen plus oxygen gives rise to H2O. So 2H2O, 2H2O. This is the balanced equation. So 2 moles of hydrogen gas involved, 1 mole of oxygen gas involved to formation of the water. So same thing. So here reaction is 2 water molecule reverse. I am writing 2H2 plus O2. So the 2 hydrogen or 2 moles, 1 mole is, so that's why 2 moles of hydrogen gas is liberated in this electrolysis process. Why? Because here involved 2 moles, no? That's why here also released 2 moles. So this is combination reaction. This is what? Combination reaction. This is decomposition reaction. This is decomposition reaction. So these electrolytic decomposition reactions are called as electrolysis process. Electrolysis. Lysis means break. Lysis means what? Break down. Break. So okay, this is about which one? Electrolytic decomposition reaction. So okay, here question is where oxygen gas is liberated? At cathode or anode? Anode. Oxygen gas is liberated at anode and hydrogen gas is liberated at cathode. Which electrolyte is added in this activity? Sulfuric acid is the electrolyte. Sulfuric acid is a electrolyte. So okay, these points you should keep in your mind. Easily we can understand this electrolytic decomposition reactions. So already we discussed thermal decomposition reactions, at the same time electrolytic decomposition reactions. So then in the decomposition reaction, last one, photolytic decomposition reactions. Photolytic decomposition reactions. So they given activity 1.8. In this activity 1.8, silver chloride. How many grams of silver chloride? So what is the silver chloride color? It is a form of liquid like water. Like water it is present. Silver chloride means AgCl. It is color means like water. What is the color? Like water. How the water looking like water? It should look like a water. Then, so you have to take in this silver chloride in the China dish. China dish, like this is a China dish. So in that China dish, we have to add a silver chloride and keep it is present in the sunlight. We should keep in the sunlight. How much time? Some time. So later what happens? Later what happens? The silver chloride color is changed to black color. Silver chloride color is changed to black color. See, silver chloride color is this silver chloride color is actually gray color. Sorry, black color I said, so gray color. It's okay. It is converting to gray color. Converted into gray color. So the actual I said no, silver color look like water, like white. So the white color is changed to gray color. See, silver chloride, AgCl, in the presence of sunlight, it is converting to Ag plus Cl2. Ag plus Cl2. So this silver chloride color is white color. Silver chloride color is white color. This silver color is gray color. So it is its physical state is also solid. Say here silver solid. So it's pure silver. So chlorine gas. So it is escape from the silver chloride. Escape from the silver chloride. This chlorine is a gas. So okay, at the same time, same reaction is on one more compound we have take a silver bromide. Silver bromide. So this is also solid. In the presence of sunlight, the silver bromide is converting to silver and bromine gas. Silver and bromine gas. So what is the silver color? Gray color. So this is a gas. So here actually white color is changed to white color silver chloride is changed to gray color silver. So okay, at the same time this brown color silver bromide is converted to gray color. In these two cases, chlorine gas and bromine gases are liberated or released. So okay. So here, is it decomposition reaction or not? Yes, it is a decomposition reaction. Why? Because one component is splitting into the two or more components. So in presence of light takes place, sunlight it takes place. So that's why this reaction also called as a photolytic decomposition reaction. What do we call? Photolytic decomposition reaction. Photolytic decomposition reactions. Why we are called as photolytic decomposition reactions? So the decomposition reaction takes place in the presence of photolight. Photo means here light. Here we taken sunlight. So, okay, this is about photolytic decomposition reactions. So here different questions they will ask what happens when silver chloride is kept in the sunlight. What happens means we can write equations. So, okay. So sometimes they will give for directly balanced equations also they will do. So and one more thing, these two reactions are used in the where you have to use black and white photography. We can use black and white photography. We can use these two reactions black and white photography. So because they are used with the silver chloride solution, then automatically gas can escape. So finally we can get the photo. Once you observe this olden days, we have to use at that time no printers. Yes, so they can develop in the laboratory. So nowadays we can take the printout. So okay. So those days nothing. So that's why these two reactions we can use in the black and white photography. Black and white photography. So okay. So this is about photolytic decomposition reaction. So now they given one question. So you have to try to answer this question. Take about 2 grams of barium hydroxide in the test tube. Add 1 gram of ammonium chloride. Add 1 gram of ammonium chloride and mix with the help of glass rod. Touch the bottom of the test tube with your palm. So what do you feel? Is this an exothermic or endothermic? Exothermic or endothermic. Generally, when new product is formed means automatically we can get the some amount, it releases some amount of heat. So all combination reactions are exothermic All combination reactions are exothermic reactions. All decomposition reactions are endothermic reactions. So what is the difference between exothermic and endothermic? First of all, you should learn this. Exothermic means what and endothermic means what. So everyone should give endothermic. How we can find out which is exothermic and which is endothermic. Exothermic means heat liberated. Heat liberated. Liberated means released. In which chemical reaction heat is liberated or released, those reactions are called exothermic chemical reactions. Exothermic chemical reactions. And endothermic means in which reaction heat is absorbed. It is absorbed. Those reactions are called endothermic chemical reactions. So just you can see saw this decomposition reactions. All decomposition reactions are endothermic reactions. Why? Because we can provide the energy. We can provide the energy in the form of heat, light, electricity. So these are these different forms of energy we can provide it in these three activities. Okay, so let's next we will discuss this about double displacement reactions. We can discuss regarding this. So now we learned, I think, exothermic reactions and endothermic reactions. Exothermic means heat liberated, endothermic means heat absorbed. So all decomposition reactions are endothermic and combination reactions are exothermic reactions. So next, a solution of substance X is used for whitewashing. What we can use for whitewashing? Calcium oxide. What we can use it for whitewashing? Calcium oxide means, so calcium oxide will use. This is a quicklime. It is basic product for whitewashing. So name the substance X and write formula. So what is the name of this calcium oxide? This name is quicklime. Write the reaction of the substance X named in above with water. So what happens? This one react with water. See, calcium oxide with water to form calcium hydroxide. So this is called as quicklime, and another name is calcium oxide. Calcium oxide. CO means calcium oxide, and this is a slacked line. What do we call? Slacked line. So another chemical name is calcium hydroxide. Okay, so this is the reaction. When the calcium oxide is reacting with water, it can produce calcium hydroxide. So this is the answer for the question. So here formula is calcium oxide, CaO. Next, So it is regarding this electrolytic decomposition reaction. Electrolytic decomposition reaction. Electrolytic decomposition reaction. So here, why the amount of gas collected in the one of the test tubes in activity 1.7 double the amount of other. So name this gas. What is they asking? Why is the amount of gas collected one of the test tube double the amount of collected in the other gas? Collected in the other. Doubled. So here, electrolysis reaction. So hydrogen H2O is decomposed to form hydrogen gas and oxygen gas. So which is doubled? So where the hydrogen gas is liberated at cathode. Where the hydrogen gas is liberated at cathode. Where the oxygen gas is liberated anode. So which is doubled? Hydrogen gas is doubled than oxygen gas. Hydrogen gas is doubled than, and why? Because here 2 moles of hydrogen gas is involved. Here 1 mole of oxygen gas involved. Because of this reason, the hydrogen gas is doubled than oxygen gas. Okay, here 2 moles, which gas hydrogen gas is involved, and 1 mole oxygen gas involved. So that's why. So hydrogen gas is always doubled than hydrogen gas. Hydrogen gas is always doubled than oxygen gas, sir. Hydrogen gas is doubled than oxygen gas. This is the reason. So next, very important reaction, displacement reactions. Displacement reaction. So in this displacement reaction, we have to take iron nails. What we have to take? 2 iron nails we take. 2 iron nails. So okay. At the same time, so their iron nails are rubbing with sandpaper. Why we are rubbing with sandpaper? Iron nails. Why we are rubbing with sandpaper? Means any rust is formed in the surface of the iron nail can remove. So if rust formed means thin layer form means the reaction does not take place. Because of that reason, we can rub with sandpaper. And take 2 test tubes marked A and B. Each test tube will take 10 ml of copper sulfate solution. So here showing only 1 test tube. In 2 test tubes we have to take. Each test tube what we can provide copper sulfate solution, which color is blue color. Copper sulfate color is blue color. So okay, and copper sulfate solution in the test tube be for 20 minutes and keep 1 iron nail aside comparison. So we have to keep 1 nail separately. One is inside the copper sulfate solution, another one is kept outside. After 20 minutes, take out the iron nails from the copper sulfate solution. Compare the intensity of blue color. So here blue color is there, no? So okay. Intensity of blue color of copper sulfate solution in the test tubes. Compare the colors of iron nails dipped in the copper sulfate solution with kept aside. So okay. So here whatever we kept in this iron nail taken out from the, so which is present in the, actually where you kept, where did you kept this copper sulfate solution. So this is kept in the outside. So copper sulfate solution, just we had 1 test tube, just we didn't add any iron nail. So this color is same blue color only, has not changed. But here after we are kept iron nail inside this test tube, no, the color is changed to pale color or pale blue or pale green. pale blue-green color is, you can observe, pale blue color, blue-green color. So what happens in this reaction? Why it is changed? Because of when I kept the iron nail, what happens? What reactions we can observe? Here, based on that, we can concluding that here displacement reaction. So a displacement reaction means what? Displacement reaction means what? So in the chemical reaction, more reactive element can displace low reactive element. More reactive element can displace the low reactive element. So here we can take one salt, one metal. One salt, one metal. So the salt containing metal is always less reactive than metal. Then only the reaction will take place. Then only the displacement reaction will take place. Otherwise, it does not possible. So let us see the reaction. So iron nail means this is iron. So where did you get copper sulfate? Where you can get copper sulfate solution, aqueous. So what happens? Ferrous sulfate solution formed and copper is deposited under the test tube, down the test tube. So in this reaction, iron has displaced or removed another element, that is copper, from the copper sulfate solution. Means here iron is a more reactive element. Iron is a more reactive element. Copper is a less reactive element. So more reactive element can displace the low reactivity element copper. So here which one came? Iron came. So okay, more reactive element can displace the less reactivity element from the copper sulfate solution, that is copper. So okay, understood? So copper is coming out, iron is adding to the copper phase. Okay, this is the thing. So here this reaction is called simply displacement. Okay, more reactive element can displace the low reactive element. Understood, ma? So we have to understanding that this displacement reactions, we should learn one concept, that is reactivity series. Already it came in the 8th class metals and non-metal chapter, but to focus or not, I don't know. So now I'm showing this reactivity series. Everyone should remember this reactivity series. In this reactivity series, the metals and non-metals, arranged decreasing order of their reactivity. Decreasing order of reactivity. So this is top, most reactivity is decreasing, least reactive. So in that 13 elements are present. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So here hydrogen is a non-metal. Okay. So most reactive elements, potassium is potassium. Everyone should remember this. You can by heart this reactivity series. Potassium, sodium, calcium, magnesium, aluminum, zinc, iron, lead. After hydrogen, copper, mercury, silver, gold. So this hydrogen reactivity is more than these elements, copper, mercury, silver, gold. So okay. So some other example. So everyone should remember this reactivity series. If you are understanding this reactivity series, easily we can find out the which is displacement reaction. So let us see zinc and copper sulfate. Zinc sulfate and copper. So here zinc is more reactive. Zinc is more reactive than copper. Zinc is more reactive than copper. So once you see the reactivity series, zinc, where the zinc is present, here zinc is there, copper. So zinc is more reactive than copper. So that's why this zinc can displace the copper. Zinc can displace the copper. Zinc is coming to here and copper is coming to the outside. So what I said, more reactive element can displace the low reactivity element. So here which is more reactive? Zinc is more reactive and copper is less reactive. That's why zinc can displace the copper from the copper sulfate solution. So this is which reaction ma? Displacement reaction. Displacement reaction. So next, one more example you can observe here. One more example, lead, copper. See, even lead is a more reactive than copper. More reactive than copper. So once you observe this reactivity series, lead is more reactive than copper. More reactive than copper. So copper can displace the lead is displace the copper from copper chloride solution. So copper is coming out. So this is going to here and this copper is going to out. More reactive element can displace the low reactivity element. So it is what is the reaction? Displacement reaction. And here I am giving one reaction. So whether the reaction takes place or not. This reaction takes place or not. So copper is already we know this is less reactive. Zinc more reactive. So copper can displace the zinc to form copper sulfate and zinc. Is it possible this reaction? No. The reaction takes place or not? No. This reaction does not take place. This reaction does not take place. Does not takes place. Why, sir? Why it is not takes place? The reason is copper is a less reactive element. So copper cannot displace the zinc. Copper cannot displace the zinc. Why? Because it is a low reactivity element. Cannot displace the more reactivity element. Cannot displace the more reactive element. Cannot displace the more reactive element. That's why these products cannot form. So this reaction does not take place. This reaction does not take place. Okay. I hope you understood what reactions we discussed. Decomposition reactions and displacement reactions I discussed. So in coming class, I will discuss with you double displacement reactions and oxidation reduction redox reactions. I will discuss with you. Okay. Thank you. Subscribe my channel and share to your friends. Okay. Thank you, ma.